Climate extremes hit people and economies around the world hard, with the potential to cause even more damage. In the past 2 decades, 7,348 major weather disaster events have been recorded globally, including droughts, floods, earthquakes, tsunamis, wildfires, and extreme temperatures. Most of the countries with a major weather disaster event are concentrated in Asia, and 8 of the top 10 countries with a large number are in Asia. Climate change has occurred continuously throughout the history of the Earth with varying scales. After the Industrial Revolution, human factors have influenced climate change. The most obvious one is emission of greenhouse gases produced by human production activities, which has caused the average temperature of the Earth's surface to gradually rise since the mid-19th century, resulting global warming.
Most tsunamis are caused by earthquakes, but a significant percentage, about 15%, are caused by landslides or volcanoes. Some of these may be interlinked. For example, landslide tsunamis are often triggered by earthquakes or volcanic eruptions. But does climate change also play a role? As the planet warms, we are seeing more frequent and intense storms and cyclones, the melting of glaciers and ice caps, and sea level resists climate change. However, doesn't just affect the atmospheres and oceans, it affects the Earth's crust as well. Climate-linked geological change can increase the incidence of earthquakes and volcanic eruptions, which, in turn, can exacerbate the threat of tsunamis. Here are 5 ways this can happen. 1. Sea level rise. If greenhouse gas emissions remain at high rates, the average global sea level is projected to rise between 60 centimeters and 1.1 meters. Almost 2/3 of the world's cities with population over 5 million are at risk. Rising sea levels not only makes coastal communities most vulnerable to flooding from storms, but also tsunamis. Even modest rises in sea level will dramatically increase the frequency and intensity for flooding when a tsunami occurs, as the tsunamis can travel further inland. 2. Landslides. A warming climate can increase the risk of both submarine and aerial landslides, thereby increase the risk of local tsunamis. The melting of permafrost at high latitudes decreases soil stability, making it more susceptible to erosions and landslides. More intense rainfall can trigger landslides too, as storms become more frequent under climate change. Tsunamis can be generated or impacted as the landslide enters the water, or as water is moved by a rapid underwater landslide. In general, tsunami waves generated from landslide of rock falls dissipate quickly and don't travel as far as tsunamis generated from earthquakes, but they can still lead to huge waves locally. Studies predict large ice shelves, such as the West Glacier and Antarctica, will likely collapse in the next 5 to 10 years. Likewise, the Greenland ice sheet is thinning, the retreating and alarming rates. 3. Iceberg calving and collapsing ice shelves. Global warming is accelerating the rate of iceberg calving, when chunks of ice fall into the ocean. While much of current research focuses on the sea level risks associated with melting and collapse of glaciers and ice sheets, there is also a tsunami risk from the calving and break-up forces. Wandering iceberg can trigger submarine landslides and tsunami thousands of kilometers from the iceberg's original source, as they hit unstable sediments on the seafloor. 4. Increased earthquakes. There are a number of ways climate change can increase the frequency of earthquakes, and so increase tsunami risk. First, the way ice sheets may be suppressed fault movements and earthquakes. When the ice melts, the isostatic rebound is accompanied by an increase in earthquakes and fault movements as the coast adjusts to the loss of the weight. So, how can we prepare? Many mitigation strategies of climate change should also include elements of improved tsunami preparedness. This could include incorporating project sea level rise into tsunami predictions models and in building costs of infrastructures along vulnerable coastlines. Researchers can also ensure scientific models of climate impact include the project increase in earthquakes, landslides, and volcanic activity, and the increased tsunami risk this will be bring.